Hello, colleagues. Hello, fellow engineers. Let me welcome you on today's session. I'm your host. My name is Sergey, and today we will be talking about machine learning and testing. Just a quick reminder, at any point of this session, you can ask your questions at Q&A session. And in the end, when we will have some time, we will be really glad to answer your questions. Also, a couple few announcements. Like, first of all, as a quick reminder, there will be a sort of game when 3 words will appear in different parts of this video. And the first one who will collect these 3 words and send these words to admin can get a really nice present from community there. And a final one will be here about the recording. Recording will be ready in about a week after today's session, so you can review this presentation at any time. Okay, so let's get to know our presenter, Anna. So Anna is a quality architect. He has a rather deep experience in both architecture, in mentoring other architects, and she has some quite of experience in competency center as well. But that's not all. Anna is also a really nice person, and let's ask some questions. So Anna, what do you like to do besides that work? All the great stuff that you do.
Hi, Sergey. Hi, everybody. So besides of my work, I learned to ride horses right now. I used to do it in my childhood, and now I decided to renew the skills. And now I'm learning to ride gallop and targeting to participate in show jumping.
Cool. That's really awesome. You know, it's really interesting to know like that we are not just some engineers that do all the work all the time, but we're also interested in different people. So thank you very much for sharing this. Okay, let's dive into your topic. So colleagues, don't forget to ask your questions in Q&A sessions, and we will get back to your questions later on. So Anna, please proceed.
Yeah, thank you, Sergey. So today we will talk about machine learning and testing and how to add self-healing capabilities for your Selenium-based tests. I know that many of test automation engineers facing the issues of testability. So I hope this topic will be interesting for you especially. Short plan of our discussion. First of all, we will describe the problem statement. Why do we need self-healing? What self-healing tools do we have right now on the market? Then we will talk about Helenium, new implementation of Helenium like Helenium Proxy, and I will describe some use cases that we had piloting Helenium. As Sergey said, my name is Anna. Maybe you already saw some of my talks about self-healing and Helenium, and yes, I'm quality architect and specializing on assessments, pre-sales, and building open source solutions. So first of all, let's answer the question, why do we need self-healing in test automation at all? Maybe there are some options with living without self-healing. But as you see, test automation engineers facing some problems during their day-to-day work and during the product development as a whole procedure. The first problem is unstable automated end-to-end tests that may inhibit CI. Right now, as we are building CI pipelines to produce our code to production very fast and to check quality gates automatically, we need to have stable automated tests and stable end-to-end tests as well. So this problem should be fixed, and it can be fixed with self-healing. Also, test automation team spends their time to fix test automation issues rather than test product and add new tests. So this is a problem of waste that we can reduce using self-healing. Also, we know that web applications during development in Scrum, they constantly update which leads to UI changes, and these UI changes may inhibit our test automation stability. And as a result, we see that our scripts start failing, but application work as expected. So with self-healing, we want to reduce these problems. What we can say that self-healing can be a key to build our efficient test automation process and build our test automation in more stable and maintainable way. With self-healing, we want to focus mostly on regression instead of test maintenance. Also, self-healing can help us to reduce amount of failed test cases due to non-product related issues. Also, we want to reduce the effort while creating Selenium scripts and to make our testing velocity greater. Also, we want to use quality gates in CI pipelines with stable tests that will provide us with real results, how product works, and can make our development and testing faster and more reliable. And besides of all of that, we want to keep using Selenium because a lot of projects already has some test automation frameworks with a lot of tests written there, and it will be an extra effort to migrate this test to some other tools. But what we have on the market right now, I listed here some tools. There are some other right now, but these tools are the most popular and greatest, I think. So all of these tools, they use self-healing and machine learning to write tests, to maintain tests, and to integrate automated tests into CI/CD. By the following links, you can just have a quick overview of these tools. From listed tools, I like TestCraft most of all, because it's kind of a very easy integrated tool. You can describe here steps that you want to execute during your test automation, and these tests will be automatically captured from UI and will be healed if something went wrong with the UI locators and some ID will change. Also, we have a tool like Parasoft Selenium. It is integrated with Selenium framework and enables self-healing capabilities during the test runs. But what is the main issues of these tools? Except of Selenium, other tools cannot be integrated with Selenium. So you need to spend some time to migrate your tests written in Selenium to specified tool. And the second reason, all those tools, they are quite expensive. So you need to spend amount of money to enable self-healing in your project. That's why we decided to create Helenium. It was kind of proof of concept, but right now it's a separate tool that is open sourced and that can help you to improve the stability of your Selenium-based tests. Helenium, as listed above tools, it uses machine learning as well and analyze current web page for changes. So for example, if something changed on the UI, Helenium will trigger this behavior and heal test. Also, it can be integrated with Selenium tests and support advanced Selenium features like parallelization. So you can run your tests in parallel as you used to do. Also, you can run your tests on the remote infrastructure, but enable self-healing capabilities in this configuration as well. Also, it can work with iframes, with JavaScript actions to perform some advanced features. And also, it can be integrated with Selenium-based frameworks like Selenite. So you can just easily switch to Helenium and enable self-healing capabilities in your project. So the main goal that Helenium can bring to project is greener CI. It's a target why we need self-healing at all. So we can run our tests on the functional automation stage, run our tests on the remote infrastructure on different browsers, enable healing there, and have good execution results with stable tests. And these execution results, they will show us the real product quality, but not automation issues and other instability. So we will reduce test automation failures due to non-product related issues, and we'll have quality feedback about our product and can release it to production or to other stage. Helenium contains several components right now. First of all, it's Helenium Dependency. It is published on Maven repository, so you can take it from there. Helenium Dependency, it includes tree comparing library. Tree comparing is implementation of a machine learning algorithm that executes healing. So Helenium Web contains this dependency, and the main feature is that it implements Selenium WebDriver. So it overrides find element method or find elements method, catch no such element exception, and in this case triggers machine learning to heal the element. To store results of our healing, Helenium uses Helenium Backend and Postgre database in it, just to have a single place of all healings and all golden masters. So this Helenium Backend can be used by multiple projects, and you can execute and heal your tests from different machines by using single Helenium backend. Also, to generate Helenium reports, we have a few plugins like Helenium Maven or Gradle plugin. These plugins are integrated with test automation code base and generates a link to the report with all detailed information about healing. And to perform code updates, we have Helenium IDEA plugin. This plugin helps to update the code base with new healing locators. So let's discuss how it works, like general algorithm. Under the hood, Helenium uses longest common subsequence algorithm modification. So we modify this algorithm to find differences in the DOM structure, to find the target locator if it was changed by parent child, and also by extra weights for tag, ID, class, value, and other attributes like text. So if our element changes the position in the DOM structure or changes its ID, Helenium will identify it using longest common subsequence algorithm and generate new locator for this modified target element. Now let's imagine that we have our test automation framework with some simple tests like click button, button with ID button, right, on our UI, and Helenium infrastructure like Helenium Dependency, tree comparing dependency, and Helenium Backend. For example, we are trying to find our element by ID button. As we see, element can be successfully found. So we store the master locator in our Helenium backend, so we can use it as a golden master for next text executions. Let's imagine that our UI changed and new locator is a green button. But test automation team is not aware of this and didn't change the code base. If we will use simple Selenium in this case, I guess we know that test will fail because we can't find our new element by the old locator. But with Helenium, it can be done. So we are trying to find element by the old locator button. As expected, it was not found. So we pass this information to Helenium Web. It passes the page state to tree comparing, requests the golden master from Helenium backend, compares them, and generates a new list of elements that can be used as healed locators. Also, Helenium generates a score for concrete new locator, and we take this locator with the highest score. In our case, it's green button, so we are trying to find new element by the new locator, and element was successfully found. So all these operations, they are done in the runtime. As a user of automated tests, you can see just a slight delay while we are trying to find elements and then just highlight that area with a new element and click or input some text. After the test run, Helenium generates a healing report with information about the element. So what was the old locator value, what was the healed locator value, the screenshot of the element, so what went wrong, just so we can validate it in the visual way, and trigger where we can put like, do we think this healing was successful or not? If it was not successful, in the next iteration, Helenium will modify a little bit algorithm of finding new elements and will adapt for changes in the more proper way. Also, using Helenium IDEA plugin, we can update our code base. So this plugin, it just looks in the Helenium database and took from their locator with the highest score that was used for healing and perform code updates. So in the next test run, our test will be stable without healing because we updated our locator to the proper one. I guess that you have a question how to integrate Helenium with test automation framework. So it's quite easily. First of all, you need to add Helenium web dependency to your project. Then start Helenium backend. Without this second step, nothing will work because it's an important thing to store the golden masters and to store the healing values. After that, you can add Helenium Maven or Gradle plugin, depending on what build tool you use for your test optimization. Report plugin, Maven or Gradle plugin will generate healing report after test run. And to perform code updates, you need to add Helenium IDEA plugin. So it's available in JetBrains and can be installed in a few clicks. Then to enable self-healing, you need to wrap your WebDriver with self-healing driver. So it's the main thing that you need to do to enable self-healing capabilities in your Selenium tests. And it's the entry point for Helenium, just to monitor with what elements are you interacting in your test automation. And in this case, Helenium can trigger algorithm and execute self-healing. After wrapping your driver with self-healing driver, you can specify Helenium properties under test resources directory. Helenium uses default configuration, but you can override it and put recovery tries, like how many times you want to try to execute healing during the test run. Score capability, in this case, 0.7 means that healing will be applied for elements that are 70% matches target locator. So if Helenium will generate new locators with score capability less than 70%, healing will not be applied. Also, you can enable or disable healing for the concrete run, just specifying heal enabled like true or false. And two important parameters here are also server host and port. It's parameters where your Helenium backend is running. By default, Helenium uses localhost and port 7878, but you can redefine it if you start Helenium backend on remote machine, so you can put host to this remote machine in the properties, and Helenium will look there to store locators and to grab healed locators from that machine. And to find elements, you can simply use standard finds element method or find by annotation. So nothing to do here. It's quite simple. And one more thing, if you want to disable healing, for example, to verify that the element is not present on the page, you need to use this annotation, because in other case, Helenium will catch no such element exception and will try to heal element. So if you put disable healing annotation over your method, healing will be disabled for all elements that are described in this method. If you want to see more examples, for example, how to integrate Helenium with HTML elements, how integrated with Selenite, enable report portal capabilities, simple Selenium, or how to wrap it with remote WebDriver, you can use this link to our GitHub, where you can find all the examples. And next topic that I want to cover here is Helenium Proxy. When Helenium was finished with proof of concept and moved to MVP phase and like a single product phase, there were a lot of questions of what languages do you support? Do you support JavaScript? Do you support Python, etc.? At that moment, we supported only Java language. And we were thinking of how can we support other languages to enable self-healing there and to integrate Helenium with other languages. So we decided to use Helenium Proxy. The idea here is quite simple. I guess that all of you knows that Selenium works over JSON wide protocol, and it's standard protocol for web testing right now. And it is kind of RESTful web service that use JSON over HTTP, and every remote WebDriver should implement this RESTful web service. So it's kind of description. For example, if we want to find elements or find elements using JSON wire protocol, we just need to execute the following commands. These commands was taken from the official JSON wire protocol documentation. You can also find it on the GitHub. It's open for everybody. So with JSON wire protocol, we can kind of write our own Selenium or something like this. So the idea is simple. We can just investigate how our tests are communicating with the WebDriver over JSON wire protocol and put healing there. Some terms here. This information is also from official JSON wire protocol page. So first of all, we need to have a client, the machine which implements WebDriver API. Also, we need to have server. It's where remote WebDriver is running, or the server can be also our concrete driver like Firefox Chrome driver. So it's our driver. Session is kind of corresponding line, and our client communicates with the server during this session. And web element is a single element on our DOM page. So how can it look like? We have our, for example, JavaScript test, Selenium client there. It's kind of our standard Selenium dependency. It communicates with Selenium server over JSON wire protocol. Server trying to find element. And then we have response that element, for example, being found. And this response comes to Selenium client, and it tells our test that element was successfully found. So Selenium is kind of, it implements this communication between client and server. And we think about how to, maybe we can put a proxy between client and server, and just to monitor how these guys are communicating with each other. For example, if we receive from Selenium server that element was not found, we can catch this in our Helenium proxy, enable healing in this moment, and then try to find our new element with healed value. Element will be found, I hope, and we will pass a new found element through our proxy to the client. So our test will have the result from server, like element was found, and it will be not aware of used vProxy or not. It will be just a standard communication for this client. In this way, we can write our tests on the multiple languages and just target them not on Selenium server, but on Helenium Proxy that will do all the job, like proxying requests to server and proxying responses from server, and enable healing if some of elements was not found. So this configuration is under test right now. It's already implemented, and we hope to open source this approach in the nearest months. So if you use not only Java, but JavaScript, Python, or other languages, you can try Helenium with Helenium Proxy approach. And a few words about the use cases. This use cases corresponds for standard Helenium without proxy, but anyway, we tried to help one project that uses Hybris to speed up and stabilize their testing. So problem here was that the project uses several environments for testing purpose, and on dev environments and cloud environment, locators that are generated by Hybris, they were different. The same page, but different locators with some added numbers. So in this case, team integrated Helenium to their test automation framework, ran tests over the dev environment, then had the golden master in Helenium backend, ran tests over the cloud environment, and tests were passed. So they reduced number of page objects because they used to support 2 page objects, one for dev and one for cloud environment. But with Helenium, they need to use only 1 page object, and Helenium done all his job over the 2 different environments and implements self-healing there, and helps the team to reduce time spent on new tests writing and on test stability. The next example was with localization testing. So the project uses to test auto-generated page for English, French, and German locales. And they used to support 3 page objects for these 3 locales because locators was auto-generated and it was hard to maintain them. With Helenium, they reduced time on test maintenance, and also they speed up their team velocity. What issues we know right now about Helenium? Very popular question is with false positive results. So yes, Helenium can bring false positive results to the test automation, but if you use proper assertions, like be sure that you are interacting with the right element, this will not happen. And also one issue that we know, it's about the test speed. So it can be, your tests can run a little bit longer than they used to, but this issue is in plans for fixing. Also some limitations that we know, it's weak behavior when site is pure. So when there are not much options for comparison of what have changed. In this case, probability of the wrong healing is higher, but anyway, healing is still quite good generated, and algorithm is working quite fine. False positive results. So to reduce these issues, you should use proper assertions. With Selenite, you can see the speed decreases for about 30%, but this issue is also in our backlog. To verify that element is not present, you should always use disable healing annotation. You should always have a golden master with past tests. So for example, if you have a lot of broken tests and you want to fix them with Helenium, first of all, you need to make them pass. And then in the next test runs, they will be automatically healed with Helenium. But Helenium anyway need to have a golden master just to know what is the target element it needs to heal. And right now it generates only CSS locators, but I guess in a month it will be not in this way. Talking about future plans, we implemented report portal integration. So right now, if you are using report portal, you can install their Helenium plugin and have results about healing, some information, what elements, what tests were healed in the report portal directly. So it's an additional reporting that you can use, not just Helenium report. Also, we are testing right now JSON wire protocol proxy on the different languages, and soon it will be open sourced, so you can try it on your project. Also, we are testing right now a solution of generating user-like locators. It's limitations that I described, like right now, Helenium generates only CSS locators, but in the next version, it will generate user-like locators. For example, if you used ID to find your element, healed locator will be generated using ID. The same for class, XPath, text, etc. Also in plans is to speed up healing by implementing kind of local storage. And we want to expand our machine learning model to make Helenium greater and to work faster. And the next step that we see for this project is to implement record and playback capabilities. So you can just click your test over the UI, save them, and then run. But test will be stable because self-healing is there. Here I listed a number of links that you can follow if you want to contribute or if you want to get acquainted with Helenium. You can visit official GitHub repository and try it or contribute with your ideas, with your codes, or if you have something to bring to the project, the team will be very happy. We really appreciate your contribution. That's it from my side. So if we have some questions, we can discuss them right now. And thank you for attending this webinar.
Thank you, Anna. It was really a great session. Let's give you a minute to catch some breath. And basically, your presentation generated a lot of questions. I mean, like a lot. So we will be going through some of them because partially they were answered, and colleagues, I already posted some answers when Anna mentioned the related topics during her presentation, like about increasing the test execution time, like what kind of languages are supported. There was a question about like, is it supporting Appium? And I guess from like your previous slide, it is supporting, yes. Okay, so let's go through some more complicated or like questions that were not touched during the presentation. Like the first one will be sort of personal professional. So you're obviously not working only as an architect with this technology. So did you try it on the projects by yourself? So what your success story with it?
Yeah, so I used Helenium over that two user stories that I described. I helped that project as kind of architect to enable Helenium there. And right now, I'm mostly focusing on testing the solution on different test automation frameworks. So as I said, we are piloting Helenium Proxy. So I'm just writing some frameworks with number of tests and enabling Helenium there. But most of all, for the most projects, I was kind of consultant or quality architect that helps projects to set up Helenium and monitor how it works.
Okay. So in your experience, like specifically your experience or some colleagues that gave you feedback, so how usually successful pass ratio changes after like you introduce Helenium to the projects?
From the projects we piloted that solution, it increases from 20 to 40%.
So by quite a lot of margin. Yeah, that sounds nice. Really, really nice. Okay, so colleagues, if you're interested in this technology, so definitely go and try using the links that Anna showed on the previous slide, because like it really works.
I can go here.
Yeah, so feel free to try. This is really something that worth your attention. Okay. So there are some really like technical questions that I'm not sure that we will be able to answer 100% because it's really not so easy to describe them in chat, but sure, we can try. So colleagues, if we will not be able to do this, please forgive us. So the first one will be like this. So there are a lot of like different locators, we know that. And so let's say that you're working with some specific locators. And for example, a class was named like red button or something like this. And for some reason, like developers change the class to green button or dot green, whatever. So it changes completely. So how will Helenium work in these cases? Will it like identify that something is different? Will it try to heal? Will it fail?
So if this locator is our target and we want to interact with this concrete button, for example, yes, it was red, but it's changed to green and we still need to perform an action during our test. With this button, Helenium will identify it despite that class changed or ID changed. It will look on the parent-child, the parents and childs of this element. So first of all, it will have kind of golden master and we'll see like, okay, this red button is here and it has following attributes. If in the next test run button changed, it will try to get this node sequence to this button. compare it to the nodes of the DOM page, like in the graph, and using that longest common subsequence algorithm will generate a new locator, taking into account that this button was in this node sequence and class changed. So element is here, new class is green button, here is new locator.
Okay, okay, cool, thank you. So the next question is about React framework. So basically there are no like typical ID attributes in React framework. So how does Helenium will work with that? So will it be able to solve our potential issues?
Yes, it doesn't matter whether you have ID attributes or not. Anyway, there are other attributes for the element except IDs and classes. And also element is placed in the DOM in kind of this node sequence, like we know his parent, we know his child, and we know what parents were before his parent. So kind of this line, how can we find this element by parents? And anyway, even without any attributes, Helenium will be capable to find new element if we change its place and change his parents.
Okay, thank you very much. I hope that that was really useful. Okay, so another question regarding like working with locators, and basically I think that I already know answer to that, but let's make it sound. So if we use more complicated XPath locators like ancestors, following, siblings, etc., will Helenium be able to work with them?
Yes, Helenium is not taking account in how you are trying to find element by ID, by XPath, by CSS, it doesn't matter. It works with node sequences that it generates by his algorithm, and he stores in the database this node sequences with parents, child of the target element, and all the attributes of the target element. So it doesn't matter how complicated your locator is.
Okay, okay, got it. We have another really recent question from Kirill, who's asking, starting with Selenium 4, the JSON wire protocol is not supported and changed by W3C WebDriver protocol. So does Helenium Proxy support it and works with Selenium 4?
As Selenium 4 is in beta, we piloted proxy with JSON wire. But for Helenium 4, when it will be used on the many different projects and when it will be stable, Helenium Proxy will support it.
Okay, okay, thank you very much for your answer. I guess this is mostly it for majority of questions that I looked into. Colleagues, please forgive me if I miss something. Oh, we have just another one. Give me 10 seconds to read it. Okay, so the question from Peter. If I understand well, Helenium stores all parent and child elements properties. It looks like a lot of extra stored data for Helenium test. Do you have any statistics? How many extra data stored for each 10 to 20 character short locator?
So we need to store this holistic information about the locator just to enable healing. Right now, Helenium generates CSS locators that can be quite long, but in the next version that will be released soon, it will support ID and other type of locators. So we do not have some limitations for the storage information.
Okay, But like, do you?
If I understood right the question.
Mostly, yeah. Question was also about like, do you know like how many additional info? So, for example, we have 20 characters locator. So, how many specific additional information Helenium will generate and store to like support this locator in future? Like, how many
it will
data?
store the whole node different node sequence, so it's quite a lot of data, and it will store target locator just in the way of it was described in test automation framework. It will store healed locator, like new locator value, and screenshots are stored on the client, so it's not in database. So that's mostly all information. And class name and method name where locator was described, just to enable code updates.
Okay, so that's a lot of data. Peter, I hope you're happy with the answer. And now it's definitely it. Anna, thank you very much for your time. It was a wonderful presentation. It was wonderful talking to you and like hearing on that great information about sort of future technology, because like I love magic and this sounds like a lot of magic and something that will help test automation to be a little bit easier. Colleagues,
I hope so.
Yeah, colleagues, also thank you very much for your answers, for your questions, and I hope that you are satisfied with our answers. So just a reminder, the video recording of this session will be available in about a week, and we will be really glad to see you in other sessions of today community event. And yeah, that's it. I wish you a great day and see you later. Bye-bye.
Thank you. Bye-bye.